Good morning. It's my pleasure to welcome all of you to the second meeting in 2024 of the Federal Communications Commission's Technological Advisory Council, or as we call it, the TAC. For those of you who may not be familiar with the TAC, who are watching via FCC Live, the TAC is a diverse group of leading technology experts who've been selected to provide technical expertise to the Commission to identify important areas of innovation and develop informed technology policies supporting the United States' competitiveness in the global economy. All of us who serve on the TAC are volunteers, so on behalf of the FCC, thanks so much to each of you around the table for volunteering your expertise to give the FCC the absolutely best advice and input possible on so many important issues. We appreciate the time and effort you devote to our work. I'd also like to welcome and extend a big thanks to our FCC colleagues who have framed the issues that we consider and who work hard to keep us all on track. Now, as I've said before, it would be a significant honor to chair the TAC or to serve as a TAC member at any time, but at this particular time, as broadband in all of its forms and via all technologies now has become so crucial for every facet of American life, and yet we know that the digital divide persists in this country, our work is especially timely and important. That would be more than enough to make me personally eager to take on the work of leading the TAC, but there's more, a lot more. As FCC Chairwoman Jessica Rosenworcel said in announcing my appointment in 2022, quote, the FCC must lead the world in advancing ambitious 6G research and development. We know that maintaining our leadership in high-priority emerging technology requires careful planning and execution. There are signals that need our attention, from the need for more spectrum, to the vulnerabilities of supply chains, to the changing dynamics of global standards development. We're starting that work here and now by reestablishing the TAC and charging it to conceptualize 6G to help set the stage for our leadership. Those words remain true today, even as 5G continues to evolve, improve, and roll out more broadly, as Wi-Fi 7 begins to roll out equally broadly and improve too, as satellite-based 5G deployments have begun, as beneficial uses of artificial intelligence and machine learning to improve the efficiency of broadband networks rise to the forefront, and as advanced spectrum sharing becomes even more crucial. My point here today is that all of these technological developments are important in isolation from one another, but these technologies are even more significant and impactful when viewed together, and of course, that's the way consumers view them. The ultimate question that's always before us is how can broadband in all of its forms be improved? How can broadband be made more accessible, more advanced, and more economic for the American people? And what can the FCC do to facilitate those improvements? And that's where we come in, giving the best possible input, advice, and especially recommendations to the Commission at a time of extraordinarily important technological changes. That's what we've each signed up to take on. We do our work through 3 working groups. You'll hear from each of them this morning with readouts: artificial intelligence / machine learning, advanced spectrum sharing, and 6G. And as usual, in the 3 working groups, and then as the full TAC, we strive to harmonize many divergent views from many different technology, from the perspective of many technologies, from the perspective of urban, suburban, rural areas, and try to put that all together to reach a consensus in an actionable format for the Commission. So thank you very much this morning, and now I'll turn things over to Ron Rapazzi, the FCC's Chief Engineer, for his opening comments.
Thank you, Dean, and good morning to everyone, and welcome everyone online and here in the room. I'll keep this short. I know that the working groups are active, very active, and they're in the informative stages, having speakers and subject matter experts come in and inform the individual working groups on the various topics, and also gathering information that the working groups will use to lead towards the actionable recommendations. So without going into any deep remarks here, I'm looking forward to the updates here, and also in anticipation of what the following TAC plenaries will hold in the September and the December timeframe as we're thinking about the remainder of the calendar year. What is the art of the possible as far as getting to some of those final recommendations at the end of the calendar year, if we're poised to be able to achieve that by the end of the calendar year. I know things are still in the preliminary stages in this part of the cycle, but if there's anything that we can do to press the envelope, so to speak, I'd be interested in where we can do that. Thank you.
Thanks very much, Ron. Martin or Sean, any other remarks?
No, just thanks everyone for joining us and for your time, and especially on this hot day and longest day of the year. So looking forward to this readout, and thanks everyone.
Yeah, I'm good. Thank you.
Okay, our first order of business. Doris, you're on mute. Ah, there she is.
We cannot hear you.
Are we back?
I can hear you.
Ah, we hear you.
Wonderful. Okay, thank you. Good morning. My name is Doris Gamble, and I work in the Records Management Branch under the Office of the Chief Information Officer at the FCC. So thank you for granting me some time during this meeting to go over some record-keeping responsibilities. So the National Archives and Records Administration, NARA, oversees all federal records management programs for all agencies. And back in 2019, NARA came to the FCC to review our record keeping practices with a specific focus on permanent records. And as a result of this assessment, we established some procedures to help ensure that we're meeting all of these requirements. As you know, the Federal Advisory Committee Act requires that advisory committees create and maintain accurate and complete records of their activities, including meeting, discussions, recommendations. These records are essential for transparency and accountability, and they may be subject to public disclosure. So to fulfill our responsibilities under the FACA, it's important that we do our part to create and maintain these records. This includes taking notes during meetings, preserving relevant documents and materials, and ensuring that these records are properly organized and managed. Federal Advisory Committee records are to be maintained in accordance with General Records Schedule 6.2, Federal Advisory Committee records. The designated federal officer will share an electronic copy of the disposition authority that outlines all the different types of documentation that are required for us to accession to NARA in accordance with the retention schedule. At the termination of this committee, or whichever sooner. When I say disposition schedule, I just mean it's a line item that tells you exactly what documents you're required to keep and how long to keep them and what you do with them at the end of their life cycle. Some of them are permanent, meaning they get transferred to NARA. Some of them are temporary, which means after a certain amount of time they can be destroyed. The schedule is media neutral, meaning it applies to all records regardless of their format. So whether they're paper, whether they're recordings, audiovisual, electronic, it doesn't matter. The time frame and the disposition and retention is the same. So generally speaking, all documentation is already an electronic format, so you don't have to worry about that. And in a nutshell, what does this all mean to you? We've tried to make it pretty easy. So all you're required to do from a record keeping perspective is ensure that the DFO has a complete and accurate record that documents all of the tax deliberations, decisions, etc. The work you all do is very important, and we want to make sure it's documented and preserved. And so we've established a mailbox specific to the TAC. Every committee member should copy the DFO on all emails pertaining to the business of the committee or its working groups, and also copy the box, which is, I believe, tac@fcc.gov. And we'll make sure you all get that address. We'll make sure you get the GRS. And we're the ones that work with the DFO to ensure that the mailbox and all other related records get transferred to NARA. So just a quick reminder, everyone, we're all responsible for creating and maintaining accurate and complete records. If you have any questions or concerns about your responsibilities, please don't hesitate to reach out to myself or to your DFO. And that is all I have. Thank you so much for your attention.
Thanks.
Turn it back over to you.
Yeah, just to
Yeah.
be clear, Martin is our DFO, in case
Yes.
there was any uncertainty about that. Is there an online question, Martin?
No, I forgot to do a little bit of housekeeping, though. If, for folks in the room, especially, the mics don't activate themselves, so if you press the button, then you'll see a red light, and that means that the microphone is on for when you're speaking, so folks online can hear. And I think folks understand how to use Teams, but you're muted online as well, so please unmute to speak. We can use the raise your hand feature on Teams, and then in the room, typical convention is to flip your name card up on the side if you have a question.
Andy?
Yeah, if possible to turn the volume up in the room itself a little bit?
We'll check on that for sure. I was having the same issue. Any questions about record management? Martin is always available. He's always an email away if there are questions. Okay, great. Thank you, Doris. We really appreciate your help and your briefing. So now we're going to turn to working group presentations, and we're going to start with Andy and the Advanced Spectrum Sharing Working Group. Take it away, Andy.
Okay, thanks, Dean. Thanks, Martin. Thanks, Ron. Let's see if this works. It does, but okay, cool. Okay, so I am the co-chair of the Advanced Spectrum Sharing Working Group, and my other co-chair is Manisha Ghosh from the Wireless Institute at the University of Notre Dame. I'm representing the Wireless Innovation Forum on the TAC. So just a little bookkeeping, and this is really for people who are on the TAC itself. We meet once a week, 3 to 4 p.m.s on Eastern on Tuesdays. And if you'd like to be joined into the invite for the meeting, please send email to the indicated addresses there. Please be sure to include all 3. And if you are a vetted member of the TAC, we will add you. We are still getting requests from members of the TAC to be added, even though we're 25% of the way through. So, but anyway, you don't want to miss anything more. Please give us send us an email and let us know if you want to be added. We have a very robust group of participants in the Advanced Spectrum Sharing Working Group. The ones that are not shaded in gray here are the TAC members or alternates. And the ones in gray here are observers from FCC and NTIA. So the meetings are well attended. We have some very good discussion going on in the meetings. Speaking of discussions, what we're going to present here today in terms of the status of the various items that we've been asked to address in the charter is we have been discussing each of these individual items within the working group over the past few months since the first TAC meeting, and we've had some very interesting discussions. What we have here in the slides today are some highlights or bullet points or whatever regarding those discussions, but these are just discussions. These are not finalities. These are not any recommendations we're going to make. It just sort of gives you the mindset of the working group with regard to each of these items. So please take these as idle chat at this point, and maybe eventually it'll evolve into some type of recommendations we will make. Maybe some of these discussions will not evolve into anything. So just take what we're presenting here with that caution. Okay, so we have assigned, let me just say how we're operating. We divided all of the issues we were asked to address in the charter into individual items. And then we have asked for volunteers within the members of the working group to lead the discussions of each individual item. That way, we're sort of guaranteeing participation by members of the working group rather than leaving it to just the co-chairs to do everything. And this has worked very well. We've got a good distribution of people who are leading individual items, and also people sign up to address the individual items as well. So we've got participation by everybody in the group, as far as I recall. So this is working very well so far. And at this point, on each of the items, we really are either at the discussion phase or at very early drafts of some kind of work product that are going to come out, that's going to come out of it. So for the purpose of this meeting, we are going to attempt to let each of the leads for the items discuss that item. Several of the leads are online; they're not here. If that fails, I will do my best to address the items myself. But we're going to try to have each of the leads. Fortunately, to make it easy, the first lead is here in the room, our honorary co-chair, Amit. So Amit, let you start with charter item number 1.
Thank you, Andy. So chart number 1 basically says what do the advanced sharing frameworks and architectures look like in the future. We're trying to look in the future. And we broke it down into 2 parts, sharing frameworks and architectures. For the first part, we looked at first what is happening outside the country, and we are seeing some interesting developments in Europe. One is between licensed and unlicensed, which Ofcom started as calling hybrid sharing model, and also there is pretty well established local licensing regime that is also being, as you may know. Now, within the licensed, unlicensed, there are quite a few variations. For example, indoor, outdoor, or urban, rural, and there also is some variable spectrum priority of one versus the other. And we see some of these could actually influence or evolve, help us thought about some of these spectrum sharing regimes. Within the group, we also got feedback that there could be federal or commercial or federal commercial kind of sharing framework that may evolve. And then we go to the next slide. When you go to emerging architectures, again, we started from Europe trying to see what is happening there. That's the most common one outside the country that we see. For the licensed, unlicensed, we see contention-based sharing, inter-system signaling between, even though there may be 2 heterogeneous systems, so how can there be some signaling system established to enable spectrum sharing? There are also mechanisms of uplink, downlink split with some sharing mechanism, broadcast signaling, but there are many different architectures that are evolving there. And correspondingly, we are also projecting what are some of the additional things might happen in the US, and based on the feedback from different members of our charter. We talked about enhanced coordination systems, something like evolving the SAS kind of methodology, interference reporting. If somebody crosses some threshold, that comes into play. There's also an idea about sending a transmitter identity, sensing, income and information capability. Of course, we're looking at various fora and so on and so forth. So that's pretty much what we had from Charter 1. And I can also...
Yes, fortunately, our lead for charter item number 2 is Amit, so he can just keep going for number 2.
So for Charter 2, we had 2 separate questions, and we kind of tried to tie them together for a common purpose. First one said, how will spectrum sharing models adapt and evolve to meet the growing demand for spectrum access among various services to support multiple purposes? So here the key thing is in WRC 23, where action items for WRC 27 were defined. And one of the key things for WRC 27 is agenda item 1.13. And this agenda item is very much in line with FCC's SCS, or supplementary coverage from space. So the idea is really there is no contention between coverage from space versus terrestrial, they are very much complementary or supplementary, I should say, to each other. And there are additional agenda items within WRC 27, for example, 12, 14, 19, they're all basically geared towards protecting the terrestrial service while being supplemented by non-terrestrial networks or coverage from space, however we want to call it. And the next one on the interplay between terrestrial and satellite services will be complement and sharing models. So now we are actually going to the sharing model itself. There are, if you look at what is going on in ITU, the models that we see are mostly coexistence, not so much a dynamic spectrum kind, access kind of environment, which may come up later, but right now, all the studies in ITU that we see are very much coexistence related. Especially within the uplink direction for satellite service, there are different power limitations limited beyond the horizon categories. So this is all basically coexistence limited. Also, we are talking about spectrum sharing between terrestrial and non-terrestrial network, and these are very much geographic based. Basically, the NTN user and the TN partner will coordinate the spectrum outside the coverage of the terrestrial network. Very similar, again, in spirit to the supplementary coverage idea. Another very important part of here is the evolution of handsets, because if we don't have the same standards for the terrestrial and non-terrestrial networks, it becomes very, very challenging. Right now, the common ones are almost glued together with the proprietary coverage for the satellite service and non-terrestrial, but eventually the 3GPP based devices will make more sense. And finally, the use cases actually are very, very important. If we think of various IoT use cases and UAV kind of use cases, those sharing technologies will be very different from the commonly thought of the mobile broadband kind of use cases we are talking about. And as we go forward, we build much more on these fundamental things. Thank you, Andy.
Okay, thanks very much, Amit, for covering items 1 and 2. I mean, have we had any really quick high-level questions, or do we want to just keep going? Ron, of course.
I should know that by now. In the ITU, you mentioned that most of the studies are geared towards coexistence versus dynamic sharing. What do you think will be the hurdle that has to be overcome to get to that level of analysis in the ITU setting?
Instead of coexistence, going into the dynamic sharing, is that what you mean?
How do you take it from coexistence studies to actual dynamic sharing?
So I think fundamentally it is very, very challenging if you have in the same geography, if you have the terrestrial and non-terrestrial networks. Unofficially, we have seen several studies, and basically it is said pretty much impossible. So the only way, or the practical way that you can share is if the downlink is towards Earth stations rather than individual handsets or say dishes on top of homes, etc. That if it is to the Earth stations, that is still feasible. But if the satellite downlink is pretty much all over as a mobile satellite service, it is practically impossible to do that. I mean, some sort of, say, frequency separation or a time separation has to be done. Ideally speaking, they talk about even synchronizing that particular satellite is using versus another satellite is coming in. But practically, it is very, very challenging, and I don't see it coming up, at least for WRC 27. I don't see that coming up.
Thank you.
Thanks.
Ricken?
Yeah, and that's technical answer, and that's all valid. I agree. But I think with respect to ITU, we also need to find friendly nations who actually look to FCC, who look to US to get the lessons learned that what we have implemented. I think it's a matter of identifying the bands that they are considering, similar to what we have here in like either CBRS kind of framework or in 6 GHz, what we did with AFC. If they have similar bands or similar interest along those lines, I think then we can do a little bit more of a hand-holding and guide them into how this can be done with all the technical parameters they are identified. I think it's important to there are countries out there who are actually looking into doing that. It's just a matter of reaching out to them either through ITU platform or maybe outside of it.
Good, okay.
I wanted to ask, yeah, I had a quick question, which is, so the first part of the first part of your presentation, what struck me is kind of there's nothing new under the sun. Indoor, outdoor sharing goes back to the original days of the original CBRS order. It was called something else, but that was a concept. That's also a concept that's been used in other services. Local licensing is something that had been started, I think, in Germany, in Europe.
Correct.
And again, is not really that much of a new concept here. In every service, wireless service I can think of, there's always a debate about the licensed service areas. So I was just wondering if you could just drill down one level. What do you think the most important trends that the commission should think about in going in any sort of new direction?
So if you can, if we take it one level above, right? So this license versus unlicensed, that is, forget about the indoor, outdoor, but if we do somehow able to do the licensed versus unlicensed, beyond the CBRS framework that Ricken was, that's something that we should be looking into from my perspective. And there are many clever ways that, especially for 3.1 as well as 7.8, as we go into spectrum ranges where there is no other option but sharing. I do have some thoughts, pretty significant thought, maybe we can talk offline, absolutely. Depending again upon the incumbencies and the parameters, I'm happy to share offline.
Okay, thanks. Keep going, Andy.
Okay, good, thank you. Maybe I made a mistake asking for questions. This will be interesting. Okay, so fortunately, our next lead is also here, Dave Gurney, representing Motorola Solutions on our charter item number 3. So Dave?
Sure, thank you. So the third item asks us to look at optimization of propagation models to make them more realistic and improve sharing while still protecting against harmful interference. Then the follow on to that was what bands can these types of models be applied to? And this is a very timely question. In fact, there's been very recent developments in this area in terms of the CBRS band. But I think in general, we all agree that clutter modeling is very important for improved propagation accuracy. Commission has gotten a lot of mileage out of Longley-Rice propagation models, which are sort of don't really consider buildings and foliage and other important propagation effects. So there's a realization there that we can do more. So that's important. Very recently, kudos to the FCC, NTIA, and DoD because we've made some very significant improvements in the propagation models for the CBRS band very recently. We're taking into account things like P2108 clutter models, use of median propagation modeling, as well as system loading factors, transmit duty cycles, those types of things. All those types of things improve accuracy in general. So that's a good direction to go in. The 6 gigahertz band, of course, also includes propagation clutter modeling. NTIA just had a very recent conference, ISART 2024, where they looked at propagation modeling and improved clutter modeling and trying to reach consensus on those models. These are all good developments. In terms of the other items related to propagation modeling and improving accuracy, we did some brief looking so far, and there's more to come here, but looking at distributed sensing results and how you might be able to use those to improve propagation models. I know the amateur radio community has a database where they've grabbed, I think it's millions or billions even, of measurements in the amateur radio bands below, I think it's 1.2 gigahertz, and that's all stored in the database. So there's things to do there. Maybe you can mine that data to improve models. Kind of goes along with the next one, artificial intelligence. There's a wide range of applications where AI might apply to propagation models. Some of them might be just classifying the propagation environments and clutter environments. Other things could be trying to do coexistence modeling within a band and identify interference scenarios that you might not otherwise think of. And also the AI/ML group is also looking at some of these issues as well. So overall, we strongly suggest we continue to make progress in these areas. I think they're all important improvements, and I think we can, make further progress this year. Thank you.
Thanks, Dave. Any quick high-level questions for Dave on that item? And for you who weren't tuning in, CBRS 2.0 announced at the press event at New America on Tuesday. Very exciting. We appreciate the work of NTIA, DoD, Navy, FCC on that. And again, it is all about improved propagation models. So really, really cool. Yes, Greg.
So, Dave, and we've talked about this before, but how would you weigh the value of just theoretical modeling of propagation versus things like beaconing and just putting signals out there to see how far they're getting?
Yeah, there's certainly value to both methods. I think, the databases that the amateur radio community is putting together, I think, are helpful because you get to see real-world effects that you might not have otherwise have considered. So I think, there's different approaches. I think 802.22.3, I can't remember, but I think they had a beaconing method as well, mostly for informing of usage by incumbents and things like that. So there's different methods out there. There's a range of methods. I think they're all important. It's all tools in the toolbox.
Okay, thanks.
Henning?
Related to that, we obviously now have the advantage that we have literally billions of spectral measurement devices being carried around by conscripted volunteers. And I wonder how much of that data we can actually leverage, particularly in bands that are already shared, like with 3.5 gigahertz band, to get a better alignment between the theory that mentioned and the actual reality in a quite variety of transmission scenarios.
Yeah, there's been a lot of mining that's already gone on today in different bands, mostly commercial cellular bands, but also in CBRS band, there is requirements in CBRS band for base station equipment to measure the environment, do an RF scan before they initialize. And that data is very useful. The challenge in that data is typically that you have to sort of equalize that data for all the different variables in there. What kind of antennas are used? What kind of antenna heights? Was the phone in your pocket at the time? There's a thousand different variables to consider there, but maybe perhaps over the ensemble of all that data, you can get some valuable information.
I would just echo Andy's comment about this week's announcement. It's a major step forward.
Yep. Yeah, absolutely. Okay, if there are no more questions, and I assume the upright cards are old questions, old hands. They're heading, or you don't? Yeah, you don't have any. Yeah, cool. Okay, excellent. Okay, so we will move to charter item 4, and here's our first test of the remote participation. Tom Sawanabori from CTIA and Roger Nichols from Keysight are the co-leads on this agenda item. I believe Tom is on. I'm not sure if Roger is. Tom, are you there?
I am here. Can you hear me?
Yes, we can. You want to take it away?
Yes, thank you. Good morning. Thank you for the opportunity to present to the TAC our interim progress report. So most of the work that's been done so far has been focused on question 4.1 within Charter 4, which is what steps can be better taken to facilitate spectrum repurposing efforts. So the work that we've done so far is to really analyze, do a case study, and develop some draft recommendations for technical analysis and improved collaboration and financial incentives in repurposing. The case study we looked at was the C-band. So we developed several recommendations along those lines in terms of, there was great work done in terms of identifying spectrum to clear out, work with the Earth station community. Probably some improvements could have been made with regard to how we worked with the aviation community and speccing out new filter requirements and testing those out. Those could have been done earlier and potentially, worked out. So the interagency process was clear in the FCC's leadership there. And then, I think there's still opportunity to continue to look at C-band for further repurposing. So the financial incentives, of course, were very important to provide, expeditious clearing and repurposing. And that has provided, one of the largest revenue generating auctions in the past. So that was one of the items that we looked at, and we use that as a case study. As Amit mentioned, we're also looking at and monitoring what's going on with UK and the Ofcom study to look at how 6 gigahertz could be either utilized for hybrid sharing or indoor-outdoor between licensed wireless and Wi-Fi in particular. And then I think the bulk of the rest of the year will be focused on addressing these other issues with regard to interband issues, adjacent spectrum, and so forth. So my colleague Richard Nichols and I, along with the other team members, will be diving into those areas further as we go through the rest of the year. Any questions?
We have one from Rickon in the room.
Yeah, no, it's not a question, just a comment that I think UK Ofcom is still in process. It's not fully out yet. Whatever is out, it's just like 5-6 page long, what they're trying to achieve, and it's going to be out probably by summer of next year. So while we still actually keep an eye on that, we had internal discussion as part of the working group. So I just want to reiterate that the word here, repurposing, doesn't simply mean we just vacate the band for the incumbents, but also we should try to look into some of the coexistence model as well. So while we are looking into 6 gigahertz, I think the suggestion was, and we are going to probably move forward in that, to incorporate one more case study. So C-band is one, but bring one more case study where we talk about 6 gigahertz and how AFC, a coordination process, actually was a success here in the US. So that's just a comment that I think we are going to look into that as part of the working group too.
Yeah, the Ofcom study is ongoing. It's been kicked off. There's sort of a scope in those two different scenarios, and they expect to have a readout in 2025. But we wanted to monitor that and be aware of what they're doing and learn what we can from that.
Okay, thanks, Tom. I don't see any other questions. So we will move on to the next charter item 5, and the lead on that is actually the co-chair of the group. That's Manisha Ghosh. She's working with Dale Hatfield on this particular one. So Monisha and/or Dale, please take it away.
Hi, Andy. Can you hear me?
Yep.
Yeah. So yeah, I'll start off and then I'll hand it over to Dale for his comments. So one of the things that we've started doing is looking at when we say current state of the art, and most of the charter items are really looking at what is the current state of the art in receiver technologies and what can be done to improve sharing and coexistence by building better receivers. So at least the preliminary investigations that we've done show that there is quite a difference between the current state of the art and what is actually implemented in consumer devices as well as in base stations versus what is going on in the world of research. And especially there are a lot of projects that DARPA is leading where they are trying to develop very, very good receivers for their applications. And the questions I think that we want to look into is how much of this advanced work that is happening in academia and in other parts of the government can be put to bear on consumer receivers. Andy and I, and maybe some others on the call, were at the International Microwave Symposium in DC all of this week. And there are very, very innovative work going on the receiver side. But finding those, making a way to get those innovations into consumer devices which are cost constrained is going to be a challenge. So what we hope to do with this charter item is perhaps get the work product that we are going for is maybe a review white paper which looks at what is going on in other parts of the community in terms of filters and low noise amplifiers and linear ATDs, antennas, and then come up with some kind of, I guess, roadmap as to when these technologies can be used in consumer devices. I will hand off to Dale at this point to talk a little bit about what he's been doing. Dale, are you on? I thought
Yes, I'm here. Can you hear me?
Yes.
Yep.
Can you see me?
Yes, we can.
Yep. You
Oh, hey,
just popped
good.
up in a different chair, which I like that.
So,
Thank you for the chance to say a few words here. I'm going to focus my attention here in the time I have on a very specific topic, and that's intermodulation distortion. And I'll just read here. As a teacher, one of the things I dread is explaining to non-technical people what intermodulation is, and it's a difficult issue, but in my opinion, it's going to be becoming even more important, or better said, we don't know enough about it in a dynamic environment. Let me just read. Intermodulation distortion occurs in RF systems when multiple signals mix together in a nonlinear device or medium, such as an amplifier, mixer, or even the transmission medium itself, what we call the rusty bolt problem in some cases. This mixing generates new frequencies, the sums and differences of the original frequencies and their harmonics. These unwanted intermodulation products can fall within the bandwidth of the desired signal, causing interference and degrading the performance of the radio system. So what it means is that two people could be operating completely legally, and the distance between the signals is such that it would generate a signal within the receiver that I'm interfere with the desired signal in the receiver. And it can be, for example, the two signals causing the problem could be far out of band, but if the front end of your receiver is wide enough, when they get there, they could actually cause a signal to fall into the desired signal passband. This is troublesome. Uh, uh, for example, especially when you mix high power, for example, high power radars and bring them into the mix with very sensitive receivers that you're trying to receive, and you get this intermod. And it's more. We talk about repurposing spectrum. Well, when we repurpose and we shuffle these things, the combinations and permutations that you get go up astronomically. So now we have a situation where the situation is not only changing statically because of repurposing, but it's changing on a moment by moment basis. And that is really troublesome. It's troublesome from a troubleshooting problem. Uh, it may be transitory. In the old days, when we had high transmitter towers and so forth, intermod was you could sort of get your hands on because things were relatively static and so forth. But that's no longer the case. And as I mentioned, it can be even within your equipment itself that the intermodulation can be generated. I think I better stop there. But my concern is we just don't know enough information. I don't want to say, hey, this is a problem, because we don't know enough. So my own feeling is we need to have more meetings with people who actually fight these kind of problems on a day-to-day basis to see, in fact, what the situation looks like, and then try to forecast it a little bit. Try to look at what it might be as we increase densification and the mix of devices and the bandwidth.
Great. Thanks, Manisha and Dale. Any quick questions on this charter item?
I'll just say I totally agree with Dale here. Intermodulation interference has always been kind of a mysterious black box. It was the times that the commission has addressed it. The one that is most notable in my mind is the 800 megahertz Nextel, and complete reshuffling took years, took lots of time and money, and I think absolutely it's an important area for research. It's always seemed to be kind of a mysterious but pernicious area of interference.
Yep, agreed. Thanks, Dean. Okay, I don't see any other questions, so thanks again, Manisha and Dale. Oh, sorry, Greg, sorry.
Yeah, Dale, I didn't hear you mention it, but could the biggest issue with intermodulation not be direct interference, but rather raising the noise floor everywhere for everyone?
Yeah, we've been talking too much in the meetings. Yeah, as many of you know, I'm very worried about just a rising in background noise. I mean, all these things sort of come and go, they jump around, and so you don't see, something that you can put your hands on, but rather what it's doing is just raising the background level, the background noise level, and because you can't, like say, pick out a distinct signal. So thank you very much, Greg. I should have used the opportunity to say that that's I think another thing we have to be concerned with in that rising background noise.
Great. Thanks, Dale. Thanks, Greg. Okay, I'm not seeing any other questions. So the next three charter items are all led by the same person. So for efficiency's sake, let him go through 6, 7, and 8. And then if there are questions, we can go back. So Jason, I hope you're online. Are you there?
I am here. Can you hear me?
Yep. So take it away, and let me change to the first one, and I'll just follow along.
All right, great. Thanks to the commission for the opportunity to speak here. Just want to, first off, remind the committee that the words, this is preliminary discussions and hypothesis. I'm pretty passionate about two of these topics, and it'll probably come out, but we still have a ways to go to arrive to consensus. For some reason, I can't see the slides, Andy. I apologize. No, thank you. So 6.1 and 6.2, what are the candidate bands or services that can coexist with low power indoor operations such as factory automation? And what are the sharing mechanisms to consider? This is an interesting field to study. My background is mostly commercial implementations in large manufacturing facilities. So one of the things that we raised with the commission, with the working group, is that we think that there are opportunities potentially to use the spectrum that's already available more efficiently, and maybe propose a way that we could use some of the unlicensed spectrum, or unregulated spectrum that's already available in a more unique way to enable the FCC and the committee to be able to use that spectrum more efficiently. Examples of that are technological. So one of the ways that we thought about answering this question was considering the utilization potentially of existing unlicensed bands for this type of use case, and how we could use backhaul spectrum for other purposes. That's a hypothesis. We're under a review right now on what that might look like and what are some working examples that we might be able to bring to the committee. I'll pause for a second. Are there any questions for that issue?
Not seeing any right now. Jason's?
Okay, next item.
Yeah, I'm trying to change the slide. Yeah, there we go. Okay, it is changed here.
This is in reference to the 95 gigahertz spectrum plus passive services. This, we really believe we're working with subject matter experts. We're going to do a review within the commission or within the working group to really dive into this. This is an interesting play, and we've seen some examples of university research where this could be highly useful, potentially, especially in the application of Open RAN solutions. Any questions on this item?
Not seeing any in the room, so we can proceed on.
And then the last questions, Charter 8, what role should sensors play in informing spectrum use? This was an intentionally provocative proposal. It is a working hypothesis. It has absolutely no consensus at this point, but it is the hypothesis that we're working around. And the hypothesis really comes down to how can we use sensorization in order to do utilization and quality of usage metrics on these existing spectrum bands, and then potentially use that information to be better stewards of the spectrum. Perhaps a dynamic SAS with a ability to run AI and figure out what is being underutilized and potentially reallocation of that spectrum. This is something that has to be discussed, but these are the kinds of thoughts that we're thinking. That the key theme is, how do we better leverage the spectrum that's already been allocated in specific use cases for that purpose, and how can we insert the right level of metrics and solutioning to address it? Any questions on that?
No, I'm not seeing any in the room, Jason. So,
Thank you very much, Andy.
yeah,
Thank you to the commission for the opportunity.
Yep, thanks. Very efficient. Thank you for your presentation. Okay, so we will move on to the next to the last item, charter item number 9, which is led by Rob Alderfer from Charter. Rob, are you on?
Yes, I am. Hi there. Greetings, everyone.
Yep.
So for this item, the commission has asked us to look at the intersection between spectrum use and sustainability and energy efficiency, which is very timely, not just because it's a hot day in Washington, but also because when you think about where the growth in commercial internet traffic is coming from, it's often coming from very local, specific use cases, so homes, businesses, venues. And so there's certainly an opportunity to think about serving that local traffic from local networks and dense network architectures. So we'll be diving in on this topic, inviting some subject matter experts to weigh in, including Dinesh Baradia from University of California, San Diego, who has a team that's done some work in this space, as well as other experts and the experiences of members of the TAC. So we'll be synthesizing all of that input for this item. That's all I had. Any questions?
Any questions in the room?
I'll just make a comment, which is, so you're doing a great job here of faithfully breaking down the charter, which has a zillion questions into these various topic areas. Andy and Monisha, just really great job that way. And the only comment about this one is just, I would hope that although it's framed in the sense of trade-offs, it may well be that actually efficient spectrum use and greater sustainability and energy efficiency actually work together and are not inconsistent with one another. So I hope we're not just assuming from the beginning that those concepts are at war with one another.
Yeah, and I should have mentioned at the beginning, when we started looking at the breaking down the charter items and individual discussions, we realized there's a connection among many of these different charter items, and I think our final output will reflect that. But yeah, we definitely, in a way, item 9 can be a recurring theme among many of the other charter items, and also 10 and 4 are kind of tightly connected. So we will recognize that in whatever comes out.
Thanks, because, I mean, you just think about it at the highest level. You have a cell that's lightly loaded. It doesn't need gigantic amount of spectrum, and therefore it doesn't need a gigantic amount of power.
Right.
That's the way I'm thinking about it. So thanks. And thanks, Rob.
Yeah, when you realize and you do the back of the envelope calculation that a 5G cell, one cell, running 100 megahertz wide, can use, on average, as much power as several, 7 to 14 homes for one cell, it's pretty eye-opening about the amount of power used in some of these 5G systems. So efficiency is going to be an important consideration.
Totally agree. We don't want to be like, Bitcoin miners here.
Right, or data centers.
Exactly.
Yeah, okay, very good. Thank you, Rob. Any other questions? Nope. Okay, so we will move to the last charter item for this group. And this is actually led by myself and Michael. And so we can fight as to who's going to go over the items today. Michael, do you want to? Yep.
Give you a chance, break from talking. Thanks, Andy. So item 10 of the Advanced Spectrum Charter group included 4 subtasks. What methods can support the commission in identifying the spectrum bands that have the most potential for flexibility for sharing and repurposing, what those candidate bands would be and which bands should be prioritized, how those bands should be combined or separated for federal and non-federal use, and what would be the optimal coordination process. So over the past couple of months, we've had detailed discussions on these subtasks as well as their correlation with Charter Item 4.1, and so we've worked with that 4.1 team a lot. The discussions have focused on the bands adjacent to the existing shared bands. We've talked about considerations for non-traditional services, not just mobile broadband. And what is the definition, who determines the definition, and how do you measure the definition of used in a spectrum sharing scenario, and does that need to be refined? What is the role of the multi-stakeholder groups, and should it be similar to what's already being proposed and utilized in CBRS and 6 gigahertz? What should be the coordination, coexisting requirements and impact use with sensors, and how that impacts with the use of TDD and FDD in a shared spectrum environment? Those final recommendations are still in development, but we're making good progress on these charter items through these discussions.
Great, thanks, Michael. Any questions on the last charter item? Nope. Okay, so we will move on. This is a copy. Oh, one second. This is a slide we presented during the the earlier kickoff meeting for the TAC a few months ago. And it's only up here because there are 2 new items on the what has transpired recently. And, one is, of course, this Ofcom vision for hybrid sharing in 6 gigahertz that is under discussion in the group. And then the other item, which we mentioned earlier, is the CBRS 2.0 and sort of the right sizing of the propagation models that use there, which also is relevant to some of the work of the group. So two new items have transpired since the kickoff a few months ago. I think that's it, but let me ask Monisha if there's anything she would like to add before we sign off.
Not really, Andy. Thanks for helming this today. I hope to be back in person for the next meeting. Just a quick I just wanted to say that we are working on all of these charter items, but I don't think we're going to have 10 work products, one for each charter item. We are positioning ourselves to have at least 1 work product at the end of the year, maybe 2, which will probably be a white paper, and then perhaps another couple for before the TAC concludes next year.
Yep, good points. Thanks, Monisha. So back over to you, Dean. Thank you.
Yep. Thanks so much, Andy and Monisha. Again, great job. Especially just breaking down a slew of questions into these chunks and then focusing on the work that's in front of you with some good preliminary ideas and points. So thanks. So we will now hear from Adam with the advanced spectrum sharing, with the AI, ML, Artificial Intelligence Machine Learning Group. You need the microphone.
There we go. Okay, can you hear me now? Good, okay. Let me start off by saying that there are quite a few folks that have contributed to today's presentation. And just like the warning that Andy gave on his, this is very much a work in progress. I don't think we have come to any conclusions on anything at this point, and far from any recommendations. It really is sort of preliminary work. And so I would urge everybody looking at this to sort of take it with a little grain of salt in terms of what's in the contents right now. I think in terms of contribution, Lisa Guess, who is my co-chair for the group, unfortunately couldn't be here. She's traveling today. We also have a sub-working group as part of the AIWG. That's Ardavan, who's sitting to my left, and Richard Kessler, again, who couldn't be with us. He's back up in Boston. So what we would like to do today is go through the following agenda. I think there's a lot of boilerplate, so I'm not going to go through that. But we are going to take a very quick look at the AIWG charter. Again, I'm not going to read all of this, but in the least let you think how we are considering it. I think there's so much stuff happening in the artificial intelligence world that's important to give some background and context to of the few thoughts that we have around that whole area. And then I would say when I look at the questions that were posed to us in the charter, what we have done is polled most of the working group in terms of use cases that they see as a way of examining the answers to the questions posed. Again, we have identified, I think, 12 major ones at this point. Those may change in priority as we go through the year, but it's one way of organizing, I would say, sort of the outcomes. I think it's fairly important when you start taking a look at a major use case is to also understand where it fits into the big scheme of things, and that is the technology actually mature to execute it or not, or is this purely academic at this point? So we have done a certain amount of searching through the literature, white papers, commercial activity, what's being published, to actually understand what looks like it's in the feasible range on some reasonable time scale, and not to get too excited by all the hype that's out there at this point. Okay. The next thing is that there is infrastructure and considerations that go along with the exercise of AI and ML. I think it impinges on the other two working groups. I think a certain amount of coordination is still important. And then we're going to talk a little bit about the deliverables. We have had, again, quite a few speakers who have come in, some of them tutorial in nature, just so everybody's familiar with what AI and ML can or can't do. And then some very specific applications. And we expect a few more of those throughout the year, essentially. I think that's quite a contribution from them. And I'd like to point out we actually have a speaker from NVIDIA next week. They're the guys who sort of do the hot iron on this. They have quite an investment in telecom space, so that's what we'll be hearing about next week, okay? Let me go on to, let's see, the next item. Okay, that's the membership in the group. I'm not going to spend time on that. I'd just like to say that we have 2 weekly meetings, one for the main working group, that's Wednesdays, 3 to 4, and then our sub-working group, headed by Ardavan and Richard Kessler, and that's on Thursdays, again, 3 to 4 o'clock in the afternoon. So what we're going to do is talk about what the charter is, and we've sort of broken this down into 4 buckets. The first bucket, which I think really needs to be aligned with Andy and Manisha's working group, deals with AI and ML for spectrum sharing. Probably we'll be looking at something that's further out in time, where I think there are some evolving technologies that promise some good things for spectrum sharing and what can be done both for efficiency and other issues. The next area, which we call bucket 2, it's really sort of the application of AI and ML writ large in terms of its impact on the network, its security, its assurance, and also its performance. What can you do in those areas specifically for telecommunication networks? And that's a lot more than just looking at the wireless part of it. That's an important component, but there's a lot more to it than just that. Okay? So we'll be looking at that. Bucket number 3 is the application of AI and ML to testing. We live in much more complex environments. When I look at things like intermodulation, things of that sort, if it's indeed as important as Dale says, how do you actually take a look at that so it's not just episodic, mysterious things that happen, but things that you can actually deal with? So one part is testing of the network itself. The second part is that more and more of what we do is software-driven. And I would say if you take a responsible look at the networks that we put out, it's to make sure that they're really hardened for purpose, and it's the testing of the AI and ML itself, as I would say, the secondary topic in that. Okay. Bucket 4 is really, I would say, one of the trends that we are seeing in many, many different verticals. But in telecoms, it's really sort of the softwareization of the network, a virtual function, how would I put it? Virtual functions done in software, essentially. More and more stuff done algorithmically, so computing is part of the network in some integral way. And so, again, we think of that as bucket 4. It does intersect with some of the other areas, and I think when it comes to use cases, we'll be talking a little bit about that. Okay? So if I look at the way we have organized ourselves to answer what's in our charter, bucket 1 on spectrum sharing is part of the main working group, and it's really looking at the functionality and performance, whatever you would think of as really the KPIs that should go along with spectrum sharing, including automation and things of that sort at the same time. And again, when I look at spectrum sharing, it's coexistence with things like radar, but I would say there is a lot more reasons, even within an organization that has licensed spectrum, of how they share it among their customers and things of that sort in an efficient way. Bucket 2 is looking at the functionality and performance of the network. So it may be things like ORAN, stuff along those lines. So we think of that as bucket 2. Bucket 3 is testing. I think we've had Balaji from Raghunatham from Keysight, who just got vetted recently, so he's joining the group, and I think he'll be playing quite a role in that. And the last one is really all these trends on computing and softwareization to go along with the network. So those are the 4 buckets, and as I go into the main part of the presentation, I think we'll be identifying which use cases those go with. Okay? Let's see. So the next thing is really sort of context, and we're going to start off with something we call the 7 dimensions of AI and ML adoption. Lots of literature from digital transformation folks, things of that sort. I think it doesn't have to be 7, but I think there are 7 important things that an organization has to do to actually adopt this technology. And I think it's worthwhile saying that, despite all the misgivings we may have, all the problems that are there, there is something very profound that has happened with that AI ML world, okay, that really sort of touches on the heart of what's in this charter. Okay? And the first thing is, I would say, when I look at something like software, which is increasingly part of the network, okay, the way we write and put that software together has already been impacted by AI and ML in a fairly serious way at this point, okay? And that trend, I would say it's solid. I don't think it's part of the bubble that we may be facing. So any organization that has responsibility for eventually examining what that software does, how to test it, things of that sort, really has to be very well versed in these disciplines, okay? So if I were to look at those, the first one is commitment and mindset, okay? If somebody doesn't take it seriously in an organization, it ain't gonna happen, okay? And it does mean thinking about problems in a very different way than we have thought about them in the past, okay? The second one is what we would call strategic business cases. And what this really means is the following, okay? You still want to do projects at which you succeed, so picking those is fairly important, but also sort of understanding a string of pearls, and that's the progression of projects that grow in sophistication and capability for the organization and do something of value for it is also important, okay? So planning at that level, I would say, probably in this case at the FCC level, okay, and coming to grips with, hey, what does AI ML actually mean for us is increasingly important also, okay? The next one on this is organizational structure and capabilities. And I think as we'll be talking about a little bit later, AI ML lives on data. How you share that data, how you reuse it, how you actually curate it, how you allocate resources to it, all of that becomes important. So that's also a fairly important element. And the capability of having the right folks who actually have an intuition for what's going on, and you're not at the mercy of somebody trying to sell you a bill of goods, I think is also fairly important in this. Allocation of resources, you don't make progress unless you actually put those up. Access to technology, and I think what we would like to stress is, again, having that intuition and feeling for what is mature at this point and what is not. I would say this is an area where the hype is out there like there's no tomorrow. So you got to watch it, okay, and understand what's been vetted and what hasn't been. And just because something is in the marketplace doesn't really mean it's been debugged, really taken care of, and does what you expect it to do, okay? So I think that's important. Having understanding where your customers are going to use it, where your partners are going to use it, your vendors and suppliers that you can trust in what you're doing, developing. That is important, and very much an investment and participation in the ecosystem, okay? And again, when I look at the FCC, if I were to look at either the agenda in front of the ITU, 3GPP, almost any other body, they now have working groups in AI and ML, and understanding what comes out of those becomes increasingly important, okay? So as part of the setting, I think this is pretty important. When you look at the world at large, and I think we have a source for this, this is what the world has spent on AI ML in the last 5 years. It's actually fairly stunning, okay? The US is probably the single largest player in this. I think the number is well over 300 billion in the last 5 years. And you can see that other players, okay, are also spending considerable amounts of money on AI and ML. The expectation is that for 2024, the world by itself will spend north of $200 billion on this, okay? And a lot of it may be hype. It may be the start of a new bubble, okay? But at the same time, I suspect that there is very rapid progress and real things that work coming out of all of this, okay? The momentum is there with this level of spending. If I were to look at startups in this area, U.S. alone, around 27 billion last year, okay? Quite a bit more than the federal government, despite all the noise that we're making, okay? There is a lot more being spent in the private sector at this point than is being spent by just governments, okay? And again, I think we have tried to reference everything. If you look at the areas that it's going into, the single largest area is machine learning of various sorts. That includes LLMs in it, the way this is reported, machine vision, robotics, things of that sort. But what you see that has sort of captured the imagination of the investors in the least is the machine learning. What can you get out of AI and ML that you couldn't get out of first principles in the past? Okay, if I were to go on to the next one. Oops. It's not advancing for me. Oops. Okay. This is a chart of federal investments. Actually, the FCC does show up on the chart. I'm not going to read it, but it's in the deck, essentially. Again, I look at the federal government, somewhere north of $4 billion, I think, in 24, that's going into various aspects of AI and ML. Okay? And I think for the FCC, it was everything for looking for stolen cell phones, dealing with robocalls, things of that sort that was on the chart. Okay, so the next thing is if you start looking at, what industries, what verticals are being affected. Again, almost every analyst has their list. I think we picked one which is fairly common. They called out 6 areas. Surprising to us, the first area called out was actually telecoms. Okay? And if you were to ask, this is actually, I would say, a reflection of what happens in our charter. Okay? The questions or the areas impacted, I think, that are called out are very close to the questions that we were asked in some ways. Okay? Okay, so the next thing to say, and this is work from several different years, when you start looking at the implications of AI, ML, you start looking at the patterns out there, what you find is that typically a solution or a use case really involves a whole bunch of different areas. It involves sensing of some sort, whether it's data sensing or physical sensors. It involves computing, data storage, data management, and it involves communication systems, okay? And the thing that we see is, from an engineering point of view, those usually come as a bundle, okay? The trade-offs are done across them. You know, do I compute and then transmit, or do I transmit and then compute? And in some ways, the bottom line, the value that comes out of this is what comes out of the computing and the software, okay? And I think what's important to keep in mind is, you know, do we constrain what people can do because of certain communication systems that we build, or do we pay a lot more attention to what's happening in that world, okay, and what the demands are from the computing end and computing architectures so that the communication systems can actually support those, okay? I think that's the bottom line from it. You know, I think what it says is that there's an inevitable intertwining of the infrastructures that are necessary to actually produce a solution, okay? And it's much more than just communications. So what I'm going to do at this point is sort of jump to use cases. I'll share this with Ardavan, because he'll be commenting on those that are in buckets 3 and buckets 4. And the first one is, if I think I need to go back. Yep. Let's see. Okay. Sorry, I think I jumped too fast. So anyway, we took a look at 12 use cases. I think the total number proposed was closer to 50. I think we boiled that down to around 12 high-level ones. And the first one dealt with efficient spectrum sharing. I'll say more about that. ORAN, safety and security of the network, where I think there's already a lot of deployment of AI techniques. Network control and management, planning, I would say internal uses within the FCC, testing, both at the network device level and then the outcomes at sort of the network level, detection and understanding of spectrum usage, again, lots of different outcomes from that. Emergency response and recovery, I think this one came from John Peha. And then how do you integrate, I think we heard a little bit of this from the spectrum sharing group, how do you use AI and ML to integrate non-terrestrial networks with terrestrial networks in some handleable way. And then I think on the commercial side, really the improvements of quality of service and customer experience, where there's a lot of AI and ML development already going on, okay? So if I were, and I don't think we'll go through any of these in that much depth, you know, I'm not going to go through and read all 12 of them, but just get you a feeling, I think, for what we're doing. So the first one is efficient spectrum sharing. And I would say there are really 3 aspects to this. Understanding propagation models, understanding how they interact with models of interference and coexistence, and then lastly, how can you actually automate the processes that go along with that beyond what the SASE does at this point in time. And then I would say far term, how do you build digital twins where you actually use local data and local conditions to figure out how you actually manage the network itself, okay? I think in each one of those, what we try to do is identify, I would say, both papers and white papers on folks working on this, and there's plenty of evidence that there is, I would say, strong activity going on in this particular area. I think, again, if I were to look at a specific subset of this, let's say propagation models, I think John Peha actually put together a very nice set of references. We have some more. By the way, those are all posted on the share site for the working group, okay? So you can figure out whether you like the level of the technology going into this, how mature it is, things along those lines, essentially, okay? So that was case number one. Surprisingly enough, quite a bit of literature on this already. If I were to look at both conferences, what's being published, there are a lot of folks all over this at this point in time, okay? I do sit on the Wiley editorial board, and in reviewing things, I can tell you there is probably 7 or 8 additional books in the works on this topic, okay? Let's see, let me go on to the next one. Okay.
While you're changing the slide, Adam, I just want to give a quick shout out here to Chairwoman Rosenworcel. You know, the easy thing to do in Washington, D.C. is just kind of go with the flow and chime in when people, certain people anyway, use scare tactics. And the easy thing to do with AI, ML, is to say, oh, it's going to ruin the world, and there are all these horrific things to her credit. You know, and while a lot of people and policymakers in Washington, D.C., rightly or wrongly, were kind of going with that flow, she stood alone and said, wait a minute, there are, you know, yes, there are all these horror stories that I'm reading about, but hey, wait a minute, this technology could be really beneficial in the areas that we regulate here in the FCC. So I thought I'd be remiss not to give her that shout out as you go through this.
Definitely. Let me just say, we aren't going to be reporting on this today, but we did put together a list of organizations that are working on all kinds of aspects of AI. You know, it starts off with the Europeans actually standing up a AI office as part of the AI Act, 140 people, all the way through what universities are doing, okay? And there's a tremendous amount of stuff on the ills of AI, ethical AI, this and that, okay? I would say adding yet another voice to it serves very little purpose at this point, okay? And what you don't see in some ways is what's the balance between the benefits and I'm going to say the imagined ills. Okay? And I think striking that is a very important thing to do. So love the shout out. Okay? Okay. Next area is ORAN. Ardavan, if you want to say a couple of words about this.
Thank you, Adam. Good morning, everyone. So this use case is another example of where AI could apply in telecom on Open RAN, Open Radio Access Networks, or Open RAN. And in the intelligent controller, we have provided 2 example use case areas. The first one is AI-driven Open RAN RIC, or Radio Intelligent Controller applications. Within that category, a few examples are using AI for predictive maintenance and fault diagnosis and mitigation, using AI for dynamic spectrum allocation and cell parameter tuning, and also using it for automated network performance and efficiency optimization. Another use case area is AI native algorithms in open radio units and also open distributed units for performance and efficiency. Within this category, examples of using AI are neural receivers, AI in air interfaces and massive MIMO and beamforming optimization, and also using AI for scheduling, resource allocation, channel prediction, and feedback and localization. We've provided also a number of sources and references here. Would you like to add in?
Yeah, and again.
Yes, again, there are a number of actually, this is also a very active research area. There are a number of reference books that we have cited here.
Yep.
Can we go to the previous one? This is an interesting article on 10 predictions on how AI would improve cybersecurity. This is actually the different use case. I think we went too far.
Oops. Okay. Has it okay, there we
Yeah,
go.
this one.
Okay.
Yeah,
Go
okay.
ahead.
So this is use case number 3 is using AI for safety and security of networks. And we have 4 different class of use cases here. Using AI for prevention of security threats. Examples here are trusted execution environments, also called TEE, and privacy preserving techniques. Second category of using AI is for detecting threats, remote attestation and AI/ML-based security and rapid new threat detections are another example. Countermeasure is another use case, using AI for countermeasure. Examples here are certificate revocation and re-authentication using AI. And finally, once a threat happens, using AI for recovery is another use case. We also have provided a number of sources and references here.
And every major vendor and operator has an activity in this area. If you go to their web pages, all of that, little bit of hype, but there's a lot of very real stuff going on here. Okay. Again, I would say prediction. Okay. And I think this one comes out of Ericsson. Really, sort of this breakdown of where AI and ML is being used in telecommunication systems at this point. And everything from, I would say, anomaly detection to, I think, the list that Ardavan went through. Okay. I think instead of going through, I think, every one of these, there are 12 of them. They're fairly well documented. I think we'll just sort of zip through this. But if I were to look at network control and management, very crowded area. Incredible amount of literature of what people think 6G should look like. They don't necessarily understand the processes that actually bring us there. What the ITU does, what 3GPP does, things along those lines, and what the end equipment providers actually bring to the market. But from a technical point of view, a lot of depth on at this point of what AI and ML actually does in parts of that space. Okay. Let's see whether we can. Okay. Network planning, I would say almost every major operator is all over this at this point. Okay. And I would say the maturity of the techniques tell you that there are some things that may translate into that spectrum sharing world. Because folks are starting to understand that using AI ML isn't something that's just done in the wireless spectrum. Okay, it's important for the rest of the how would I put it, for the rest of the network, and really understanding the physical environment and how that changes, and that's mostly done with TV cameras, things of that sort. Okay. How do you marry those two worlds in a purposeful way is very much part of this. Okay. And again, lots of citations on that. Not going to spend time on that. Very much part of testing. I would say if there's an area of concern is what does softwareization do to all of the systems that we're putting together? How do you test for that? If you look at other verticals, they're all very concerned with the software bill of materials to actually knowing that the stuff has been vetted, understood, things of that sort. And AI and ML plays quite a role in how you go about doing that. So I'm going to skip that. Let's see, bucket 3, testing. Okay, do you want to say anything on the testing stuff or no?
Yeah, can we go back to the previous one?
Sure, yeah.
So the first use case testing was on.
Oops.
Oh,
Good heavens. You know, this has a mind of its own.
AI. That's AI.
There must be an AI component in here. Okay. Can we get whoever is managing to remount this? Sure, definitely.
Again, I should know that by now. So one of the things that I saw in your sources had to do with, I believe it was cooperative sharing and cognitive radio. I don't know a lot about that source, but I'll dig in a little bit more. When you're referring to cooperative and uncooperative, does it relate to the information that's available on the system in order to affect AI capabilities
Sure.
to get greater sharing?
Yeah.
I think of a use
Well,
case
no,
like where
let-
you've got a
let
system
me-
owner that says, here are the 150 elements of my system, you're free to use them as you will, versus another system owner that
Yeah.
says, here are 2 of the 150 elements you asked for, make it
Okay.
work.
So let's put it this way. So to some extent in our existing systems, when we do protocols, there is a handshake between the end device and, let's say, a base station. Okay? Okay? And the important things are, for example, okay, the channel doesn't look good. Let's degrade the rate at which I'm transmitting to you. That's cooperative behavior. Okay? Now, if you now add sensors to the mix, okay, that can drive efficiency in yet a different way, okay, and becomes very important. Okay? And the question is, and I think somebody mentioned it earlier, you know, every one of our devices, end devices, for example, okay, already has signal processing capabilities in it. It is a sensor. Okay? We don't use all of that sensing power in the way we put our systems together today. Okay? And I would say for economic reasons, for tradition, for, you know, lots of different reasons of that sort. But again, if any of that is opened up and made available, the kind of constructs that you come up with will be very, very different. And yes, they do involve cooperation. Okay? I would say the last one is our whole timing architecture, the existence of beacons in various places, things of that sort, and a whole industry built around, for example, reconfigurable surfaces where you can improve the signal somebody is getting by taking a passive element and actually changing its phase or something, that sort, okay? So lots of examples in that space, Ron.
Thank you.
Okay? Okay, case 8.
yeah. So on this case, the previous use case was testing of components and devices, more on the hardware side. This use case is more on the software side. I'm going to just point out to 2 good examples here of those use cases. One of them is using digital twins for evaluating network performance. This would enable doing testing in a safe manner as opposed to actual physical testing. And the third bullet point covers continuous testing using AIML. So you can do actually continuous testing of network deployment lifecycle using AIML, which is another interesting use case.
Okay.
And again, we have provided a number of sources and references on this.
Yep. Okay.
This is by Qualcomm. This covers actually using AML for network communication networks and sensing, but within this article you also find application of AML for testing.
Yep. Okay. So I think we talked about spectrum usage. So let me sort of go on to the next topic just in the interest of time. So we finish off. So this is integration of non-terrestrial networks with terrestrial networks, and actually trying to figure out how do you chop up the problem so it becomes a tractable problem and doable in a proper way. And you know, one of the difficulties is if you're in a satellite system, you see an incredible amount of stuff beneath you, okay? How do you pick what you should be talking to, et cetera, et cetera? And it's a big problem, okay? And then the last one is both quality of service and customer experience. And what you find is a lot of the major players are already deploying stuff in this area, okay? So let me quickly jump to, I would say, the next part of this. Okay, and that is considerations. And, you know, the first one is obviously, you know, you don't want it to get in the way, but you do have to think about how the hell do you make this safe, secure, effective, et cetera, et cetera. Again, part of mindset, making sure that you have testing procedures, things of that sort in place. So here's a list of the things that you actually need. And again, the purpose of putting up there is, you know, this isn't just a casual thing. You really have to put the machinery in place to be able to do this properly, okay? And have an intuition for what you're doing. I would say the second one is, you know, somebody quite often shows up and says, I have data. Can you do something with AI and ML with it, okay? And, you know, I'm not going to say that's not a valid question to ask, okay? But I would say from an engineering point of view is, here's the problem that I have, here's how I break it down, here's how I analyze it, here's how I understand the dimensionality is actually the right one, it's tractable, it's doable, I have reduced the problem to something practical, and to do this, I need the following data, okay? And it's sort of, you know, to me, the right way of figuring out, not starting off with, I have data, do you have an answer? Okay. You really have to figure out what problems you're trying to solve. And I can show you article after article that recommends this as a way of dealing with things. And at the same time, when you go down that path, I think the level of success is a hell of a lot higher, essentially. Okay. So I would say data, fit for purpose. Let's see, next one. Okay, I pressed this, no reaction. Okay. That data requires curation, management, and storage somewhere. That's an infrastructure. We used to have projects that had everything self-contained. There's a lot of value of making that data available, okay, over and over again. And the more vetted it is, the better curated it is, the more useful it becomes, essentially, okay? And somewhere inside the organization, there has to be somebody who worries about this. Let's see, okay, pressed the next one. So am I pointing this in the wrong place? Yeah, here it is, okay. The next part is building models. This is really figuring out how do you build something, how do you use all the techniques in your toolbox, a hybrid. If there are things that can be analytical, that's what you do. But it's about exploring that problem space, exploring the solution space, and coming up with something that's practical, essentially, okay? Building those models, again, takes intuition. And again, all those questions of tractability, size, dimensionality, all of that matter. Let's see, next one. Okay. I'm going to skip that. I think we've shown that before. It's a complex cycle. It requires stuff all the way from the cloud to the endpoint. And I think the important thing to understand is, when you look at a lot of the learning that's done in these models, happens in big data centers. That's where all foundational LLMs are built, things of that sort. The flip side is, you know, your end devices, your cell phones, are all likely to have AI chips that are inference chips that run 7 to 8 orders of magnitude faster than actually the learning cycle. That's where the value comes from, okay? And so when you look at this, what you find is the communication systems, the distribution of data from various sources to actually achieve an answer is a very complex network, very different than what we've experienced in the past. And that's what's being built out today. And so there is sort of a hierarchy, things that are in the cloud, all the way to things that are at the endpoint. And if you start looking at connections in our networks today, the predominant number is not, voice to voice between a person. It's somewhere in this connected world. Whether you call it IoT, whether you call it the metaverse, really doesn't matter that much. Those are labels. But this is where the investments are going in right now, okay? Connectivity and access, up and down that hierarchy, that becomes important. And then operations. The way you operate in IT is a little different than you do with AI itself. Again, something important to keep around. And it involves a very different set of skills to get value out of it, essentially, okay? So, and then the last thing is, I would say, specialized facilities. If you look at the AI world, there are probably around 50 different technologies involved. Whether it's emulators, whether it's creating synthetic data because you have simulations going on that are feeding data to you, again, taking a look at, what is it that an organization needs to function properly becomes important, okay? Okay, deliverables, again, if I were to look at it, we took a look at the filters we're using. It's to make sure that we address the 4 issues that are in our buckets, that we consider what the FCC's strategic goals are, what we see as industry trends, technology maturity, timeliness. And I think we've started considering some of those. We haven't started taking a look at the nature of our recommendations at this point, okay? So I think that's where we are. And then I think what you will find in terms of content, this is what we expect as the work products. I would say probably having considerable in-depth white papers, but doing that in the next term in '25. So I think the results will be briefings at this point, okay? And then what follows this is a list of some of the speakers that we've had, okay? So I think I'll stop with that.
No, great, Adam. Thanks so much, as usual. Incredibly comprehensive, chock full of interesting and important information. And, there is no AI ML Bureau of the FCC, of course. So everything that you're talking about really cuts across, so many of the Commission's internal and external, processes and functions. So with that, we will turn to the 6G group. So Manu and Brian, take it away.
Thanks, Dean. So the way we'll do it is we'll start with Brian and Adam. Actually, can I steal your clicker?
Sure.
Thank you. So, Brian, I'll drive the slides for you. Just let me know when you want to move to the next one.
Great. Thanks, Manu, and good morning, everyone. Just doing an audio check. Hear me okay?
Yeah, you're good, Brian.
Okay, thank you. Well, on behalf of Manu and myself, we'll provide the 6G working group report for today. First off, we would like to thank all the members of the working group. They're listed here. Not going to go through each individual's names, but we certainly have a good variety of experts that are providing input to the working group, and we certainly do appreciate their effort and joining the team. Next slide, please. So just a quick review of the charter. Won't go into these in a lot of details, but as you recall, what we're being asked to do is to provide information on the development and deployment of 6G. Now, 6G is in its early phases, so we won't see a lot on the deployment side as we go through our charter, but there certainly is a lot on the standardization and development side of 6G technology. So with those, we'll look at advisements and recommendations on these new developments and what expectations can come, and what the FCC should pay attention to as those developments are taking place. Certainly 6G, and starting with 5G in the industry in general is looking at more openness and customizable capabilities. So we're going to take a deep dive into how this is going to play in 6G. To support both flexibility and agile services, and how that will coexist with the 5G networks. And certainly 6G infrastructure will be looked at, and what do we need the FCC to do to proactively address the needs for 6G infrastructure. As we'll get to momentarily, we'll see how 6G is progressing in the standards and international fora. It's already taken off. There's already been some work, and we'll give a report on that momentarily. And finally, what are the competing 6G visions and expectations that we're going to see on key technological points? Let's move to the next slide, please, Manu. Satellite is one of the areas that's being looked at in both the standardization as well as research areas. So consideration of small satellite development, non-terrestrial networks, frequency bands, services, those are all within our charter, as well as looking at millimeter wave and terahertz bands for 6G systems. We're also charted to look at how we're going to use 6G in various verticals, and we'll talk about one of those in today's presentation, specifically the automotive vertical, but also looking at others such as autonomous driving, augmented and virtual reality, edge computing, emergency alerting, and smart cities. And next, what advancements in localization and positioning will 6G need for network optimization for things such as beam steering antennas, as well as looking at meta surfaces. Next slide, please. Security and privacy, of course, is one of the key issues in wireless and networks in general. So we need to look at 6G, specifically how they're going to address massive data collection and processing, as well as ethical and social impacts of emergency applications such as brain-computer interfaces, as well as holographic communications. We want to also look at how 6G can ensure the security and privacy of users' data and identity, especially looking across various scenarios such as distributed ledger technologies, physical layer security, distributed AI/ML, visible light communication, terahertz, and quantum communication. And next, how will the 5G as well as 6G networks support the massive volume of mobile, IoT, and XR devices, and providing low latency, seamless connectivity for both near and non-real time, as well as trending toward real-time applications. Next slide, please. Okay. So I'll turn it over to you, Manu.
Thanks, Brian. So yeah, that quick recap early on was just to sort of showcase the breadth of our charter. Today we're not going to address every single question. I think we wanted to kind of prioritize some of the topic areas. We obviously wanted to delve into the development and the standardization work and all the different sort of global bodies, consortia, and alliances that are contributing to it. So we'll start with that, and then we'll get into some more details of what's happening beyond just cellular communications, and that's been something that we have lacked in the past. We really wanted to give that some time and effort. So first things first, 3GPP, that is sort of the body that's going to define 6G, and it sort of kicked things off with the first 3GPP SA1 System Architecture 1 use case workshop that concluded in early May. So this was a place where you had multiple different, in 3GPP parlance, organizational partners and market representation partners that were there, and they all presented their kind of work that's been happening over the past 18 odd months and their visions as to how 6G is going to be defined and what are the key requirements. Now, this workshop was primarily around motivating use cases, and I think it was quite interesting, and we've sort of been able to summarize that thanks to a presentation by the Next G Alliance to the working group, which summarized all the different perspectives that you see listed here. I'm not going to go through them, but what that represents is a significant representation from different vertical industries, but now you're also seeing specific kind of nation strategies that are being shown. So you have multiple different partners, and these are all being part of global consortia and alliances that are coming together to present those kind of use cases. The importance here is that you're not going to see any kind of ranking. So this was sort of the first formative step that 3GPP took in defining or kicking off the definition of 6G. And here are sort of some of the representative use cases. Again, maybe a little bit hard to read. I think the ones that are kind of the trends, and we'll summarize that on the next slide. I think the key ones to notice here are importance around the ubiquitous and resilient coverage. So this is now becoming a very, very important topic. And I think as you design critical technologies, component technologies, and system architecture, you're going to want to look at how do we build in resiliency into the system. And this is going to manifest itself by looking at how the physical layer performs, how the different protocols are enhanced, how do we sort of integrate satellite communications, hybrid network approaches, things in the 5G core network, things that were called like the N3IWF function. How do you sort of build multiple different comms techniques to provide resiliency in communication? The first one, which is security, always has been adjacent, but this time it seems like we are looking at this, in a holistic manner, both at the horizontal level across the different components, but also vertically throughout the protocol stack. And we're looking at positioning. That's going to be quite important. And then the thing that is very interesting to note, and I don't know what to make of it, is the backward compatibility wasn't mentioned very significantly. So there has been this kind of a push and pull with respect to defining 6G as a revolution versus an evolution, but it does seem that there was a very strong position, at least in the operator community, to make sure that that transition is smoother, given all the investment that's happening and going into defining what 5G is today. So just representing that picture in some words.
Manu, can I ask you,
please.
that was a great chart, by the way. Very, really helpful chart.
Thanks to the NGA and David Young, if you're online.
Yeah. So, but I have a question just about the workshop and whether one area came up, which is driving down end-to-end cost. We've discussed this in past TAC meetings. One way to help to ensure that 6G does play a constructive role in closing the digital divide and becoming ubiquitously available is driving down end-to-end costs so that, the underlying economics support that. And I was just wondering whether that's to what extent is that a consideration so far?
I'll let Brian and David, if you want to jump in here, feel free to do that. I'll just kick it off on the device side. So on the device side, not just the consumer side, but we're also seeing the enterprise and Industry 4.0, for example, really trying to, in their presentations, they talked about driving the device cost down because they have longer lead times and cycles for, manufacturing, et cetera. And when you are actually moving from 5G to 6G and the device cost is exponential and you need hundreds and thousands and millions of sensors for a factory floor, 1 million square foot, the economics become very, very challenging. But David or Brian, I'll defer to you if you wanted to add anything.
Yeah, let me just jump in, and David, please feel free to chime in afterwards. But yeah, I think there's a number of underlying technology aspects to drive down overall costs end to end. Certainly, there's the sustainability and energy consumption, which goes to the operations side, and that's a big push and a big theme that's being discussed both within 3GPP as well as other groups such as the NextG Alliance. So that's certainly one. And then you have openness and the trend moving toward open networks, which allows greater flexibility in deployments and deployment scenarios. So again, that looks at overall cost of operation and cost of deployment. David, I see you came online. Anything you want to add?
Yeah, the only thing I would add to that is there was a general discussion at the meeting and among participants at the meeting on the need for a solid business case for 6G. And so that obviously is cost efficiencies and allowing the network and services to be provided more cost effectively, but also developing new revenue streams, and that's an equally important part of the discussion. So I think both of those are recognized as important for 6G success.
Hey, thanks a lot.
Yeah,
Henning?
Henning.
So there seems to be a significant overlap between the applications mentioned for 6G here and the ones that I remember about 10 years ago for 5G. In that, the 5G experience might not be called the predictive power of the 5G experience, might be called into question with some justification. I think even industry analysts now see that as being less than successful. So I wonder if there is some reflection going on among these bodies to say, what did we get wrong? Why didn't this actually pan out when we predicted healthcare and autonomous driving and backward compatibility and native voice over 5G and smart life? All of these things sound very similar to 5G.
Absolutely. So I have two slides on that as to what the difference between IMT 2020 and 2030 is and how that's sort of been defined. But I think, again, I don't want to generalize it, but again, you remember sort of the triangle of the MMTC, URLLC, and EMBB chart. And I think general consensus, if we did a kind of go around the room, you would presume that the URLLC aspect is what has been kicked down the road, and that's sort of being looked at primarily from the 6G lens. I think EMBB-wise, we've been very successful, and then also for MMTC, where technologies like NB-IoT and sensing have done quite a bit. So there is also some updates we have about autonomous driving and sort of what breakthroughs have been made in that field. So I will get that to you. If you don't get that answer, then let's revisit that again. Adam.
Yeah. No,
Mike, if you don't mind, Mike Adams, sorry.
Oh, okay. So it's really sort of a follow-on to Henning's comment, okay? And that is, if I were to look at what you just pointed out, okay, and that is how do you interoperate 5G with 6G? That becomes important. But I would say the appetite to do a forklift every time we introduce a G, okay, that appetite isn't there. Okay? And in some sense, I would say if I look at the underlying technologies that we have and start listing those, it's probably 50 or 60 different technologies involved. They all mature at different rates. Okay? And so to what extent, okay, are these processes really looking at how do I modularize the network so as improvements happen, I can actually take advantage of them, okay? And then I might be able to introduce the use cases because I've crossed the right threshold, okay? And, to some extent, are we just getting too comfortable because we have done it this way for a while, okay? And maybe should be doing something different.
Yeah, so that's a great question. I think what I would point you to is this proliferation of non-public networks and private network solutions that are a little bit more customized to each of the different use cases. As you're seeing the softwareization, and we talked about Open RAN and Open Radio Access Networks, you're looking at modularization both on the horizontal side with the division of the central unit, distributed unit. Obviously on the physical layer side, that still remains to be seen because at large-scale vendors, they still have pivoted again back to ASICs rather than software-defined radios and FPGAs. But as you're looking more on the network side and as software begins to dominate, you have the ability to drop and customize network functions, network slicing, and those will be sort of customizable to each kind of an application. In the standards world, again, I'm not going to pretend to be an expert on that. There are other people in the room, but the way the standardization work is going on, you're still divided between the RAN, the system architecture, and the critical technology speeds that are operating somewhat in silo. But there is some encouragement at the first kind of official workshop that's going to happen in March of 2025. You're going to have a cross system architecture, critical technology, and RAN a joint workshop to sort of define what the requirements are going to be. So that seems to be a little bit of a paradigm shift in how the technical requirements, and at least right now we're at the requirements phase. So we're not even looking at each individual technology and how all of that is going to come together to meet the application use cases you're sort of seeing there. But Brian, anything to add from your side?
No, nothing further.
Okay.
I wanted to say one more thought on this, which is you dove right in, rightly so, into use cases.
Yep.
But as you know, many, if not all of you know, 3G was not designed like first let's come up with the use cases. 3G was what technology is going to vastly improve cellular. Vastly enough that the billions of dollars of capital investment required are going to come to the fore. It's not like brains, someone's got to raise that money from the capital markets. So, 5G was kind of a departure from that because 5G with the 3 pillars was more designed with specific use cases in mind. But, to me, there's kind of a question right at the beginning, and it follows right on to what Henning was saying, of, do we design, should there be this next G designed with these are the specific things that we're going to do, because they may not actually get done, and then what? Or should it be, how do we, as I was saying at the beginning of the meeting, how do we make broadband a lot better for people? How do we make it cheaper? How do we make it more available? How do we make it do things that in the future that it can't do today? So I'm just always an advocate for that approach, because I think when we micromanage it and try to come up with the use cases in advance, I mean, the truth is we have no idea what the actual use cases are going to be 10 years from now.
Right. So did you want to add?
Yeah, that's.
Yeah,
Sorry.
and I wanted
Sorry,
to just
yeah.
emphasize the point, the surprise use case for 5G was fixed wireless access,
Yes.
which was primarily driven by the economics that you mentioned, namely
Correct.
suddenly the cost per gigabyte of capacity delivered was sufficiently low that you could compete with wired access technologies, at least under some circumstances. And increasingly, the notion that service providers will provide these solutions, such as autonomous driving or healthcare, namely that they would be able to support the verticals, I think that model, even most carriers, unless they're talking to analysts, will probably admit that they're not likely to actually be the provider of vertical solutions in that. And I'm glad APIs get mentioned, because the ability to integrate to be a better integratable citizen of a ecosystem is probably one of the lessons that maybe we can also learn from 5G, that's been really difficult to expose those capabilities, like what I assume that the North API that gets mentioned is maybe a lesson learned. So I think it would be interesting, based on what you said about 3G and 5G, to actually look back, given that we've now gone through several of these exercises in that, what can we learn as to what exercises work well? And this is for the TAC, really, not for all these. We can't influence what these external bodies do. There are plenty of entities that you've listed here that seem to keep themselves busy doing that, but the TAC might be able to learn from those experiences.
Brian, you were trying to say something? Okay, maybe not. So
I think we have a couple more comments
oh yeah,
here.
sorry, Vijay.
Was more a question with 6G and all the different industries participating in 6G. At least in this G, it seems like different countries and governments are getting ahead of the game. They're coming out with mission statements and use cases. Is there a danger to different organizations coming out with specs which may be incompatible across regions, especially with the cost driver being open networks and open source communities playing a bigger role in adoption of new players coming in? This all being interoperable, and I see there's less focus on backwards compatibility as well. Towards the cost driver angle, do you get any sense if there's going to be a contention between different countries? Because in the past with 5G, There used to be, especially in India, in China, there were different competing standards, and you had to go through a lot of negotiations to get vendors to finally stand up and say, we're not going to go support all these different specs coming out of different regions.
So I think it's been the same way. I think as you mentioned, 5G, we saw the same thing with India, and again, those were all driven by cost because of device side, deployment side, and I think there's a sort of a fine line we're walking, which is one is on the macro side for consumer, but then the enterprise side is what we're seeing here. So with non-public networks or private network architecture, I think we're going to see a new role of either a system integrator or somebody who's providing customizable solutions. So obviously, large MNOs are already entering this market where they're working with enterprise level, but you're also seeing this a startup ecosystem where you have local markets that are going after small industries. So that local model, we talked earlier in the Spectrum group about spectrum that Germany has given. Japan is now starting to look at local 6G. Ofcom is starting to look at some frequency bands that are sort of going to prop up private operators. And I think that's where the revenue side is. So that's, at the end of the day, the equation is revenue less cost equals profit. So we're looking at it more from the revenue side when you're pushing towards the use case side, but now we'd also have to reduce on the cost side with energy efficiency, sustainability. So I think both sides of the equation seem to happen, but that small microcosm of the May 8th workshop, that seemed to be more focused on the revenue side. I think that's how I would summarize it. David, if you would disagree, please jump in here, but that's sort of the kind of sense that we're getting right now, is looking at more and more use cases, broadening the aperture, and trying to pull in more industries to bring to the table. And I think that was a very strong representation from the market representation partners to see how 6G will proceed. Rickett.
Yeah, and as far as the standardization, I mean, when you look at interoperability and potential for fragmentation, you're really starting with the ITU and the ITU vision and framework and ultimately requirements, and then the evaluation process, whether it will be an IMT 2030 standard or not. That's really what drives the radio technologies that ultimately become IMT 2030 standards. And 3GPP obviously is the main driver for the mobility standard, but there could be other technologies that are evaluated as part of that process and may have niche markets and niche deployment and applications for those particulars that may not be interoperable, say, with 3GPP standards. But as far as the mobility aspects, hopefully we'll have, maintain the ecosystem where 3GPP will define those mobility standards that will comply with the IMT 2030 and go through that evaluation process and have that fully interoperable ecosystem.
Thanks, Brian. So just to
Just quick, I'm out of time too. No, appreciate the work you and Brian are doing. I really enjoy being part of the working group there. I think, well, a quick question though. The workshop you mentioned for February, is that 3GPP workshop?
Yes, the
right?
March actually.
Yeah, it's a March.
March,
yeah.
March
Next year.
And so just tying that with what Dean and others mentioned, that's the reality, right? 3G was designed to overcome the challenges of 2G. Same way LTE was designed to overcome the challenge, the drawbacks of 3G. And when 5G came out and with the infamous triangle and everything, many believed that it could be very well be the last G. Of course, we are probably going to talk about 7G as well in 10 years. But I think my point here is that I agree with others that we should not get influenced by some of the propaganda and coming out of 3GPP and some other standardized body. I mean, 3G does a great job, no doubt, but looking at the use cases first and then trying to come up with technology, I think we need to learn from 5G because it hasn't fully delivered on many of the use cases that we have seen. So of course there is a way to go for 5G to be fully functional and fully mature, and I think it can deliver a lot of promises that we have, so we should not just jump on it. But I know we are on top of it, but just
Yeah.
a thought on that.
So I think that's the workshop, again, this is just the first thing that was kicked off by 3GPP. In parallel, you have multiple different things, and there are study items, work items on the technology side that work has happened. So I'll get into that, but if you don't mind, we'll finish that, and then you'll see sort of what's happening in the juggernaut. And I think we're going to counterbalance that next by looking at unlicensed and IEEE and 802.11 work. So that'll probably give you something.
Yeah,
I think the key.
I'd like to inject one thing there, is that we can't forget that 5G evolution has not stopped. We're in 5G advanced now, with release 18 and 19. So that ecosystem is continuing to evolve and hasn't fully matured yet. As has been stated.
That's true. Thanks, Brian. And I think these were key kind of findings that came out of the NGMN paper. And again, similar to what Adam said, we have a repository that we are collecting all this kind of good work, and some of that is distilled on the slides that you see here. So the key takeaway, again, just in the interest of time, I want to report here is around security at the network layer, but also at the user layer. And I think a key kind of an adjacent innovation that's happening is in quantum. So quantum key distribution and quantum security is going to become very interesting. So up until now, 5G's done a great job in terms of defining security on the signaling plane, et cetera. But encryption, et cetera, is going to get outpaced very fast as quantum catches up and becomes more kind of cost efficient. On the AI side, just wanted to echo what we heard from Adam and Lisa there, primarily around the network design and performance, but also the enablement of AI at the application level. And I think that battle is going to be majorly around the data side as to who controls the data, controls the models, controls the AI. So that'll be very interesting to see how that proceeds. The immersive communication, that's sort of one of the newer trends. We're looking at multi-sensor communication, digital twin technologies, and telepresence. Again, this sounds very sci-fi at this point, but it is important to see that some of those enabling technologies will come together to build architectures that can support this. Sustainability, that answers or at least acknowledges the cost side of the equation around energy efficiency and reduction of consumption, both on the RAN side, but also on the core side. And then I talked about resiliency and resilient coverage. So here's where non-terrestrial networks and remote and underserved areas, they both sort of mix together and come together. And sensing is going to be new, so there is a key interest in localization tracking, both indoors and outdoors, gesture recognition, et cetera, and technologies are being looked at there as well. So this was sort of what I think, Henning, you were alluding to is, what has 5G done and where is 6G going? So here's a new cool graphic for you, right? So on the bottom right, you're seeing this is the marketing team's answer to you, basically. But this is the green versus the blue color distinction is some of the new capabilities that have been defined within the IMT 2030 structure, and the green are the enhancements, which basically I would say human interpretation is, what didn't get done in 5G that has been kicked down. So that is coming across from the perspective of enhancements. But the key ones that we're going to look at is ubiquitous connectivity, which is you're going to look at different metrics outside just cellular, SATCOM, unlicensed, and how will that all get tied together. AI will be proliferated all the way from native AI radio interface to what we're going to see in intent-based communication, management, and orchestration, and then ISAC, the integrated sensing and comms, where the sensing channel or being able to do sensing on the same channel will be very, very interesting. And there, I think there's a lot of key technical work that needs to happen, primarily around updating channel models. And again, we talked a little bit about that in the spectrum work, and I think we're looking at new different kind of channel models that will need to be developed outside of what 3GPP has up until now to accommodate ISAC. So yeah, this was I think Brian was sort of trying to answer, Bijoy, your question around the timeline and fragmentation. I think the ITU timeline for 2030 is up there. I think a critical time that we're entering between WRC 23, out of which certain recommendations came that were documented by this group and the Spectrum group and the planning agenda for 27, if you see in parallel, the technical requirements are going to be started in the 3GPP domain. So now you're going to see sort of the work happening within 3GPP within the release 20 timeline, which will be the kind of unofficial, official definition of 6G. Because if you see on the left side, there is no mention of 6G. 6G is a term that 3GPP defines, and that sort of switch between 5G advanced and 6G is potentially going to happen at coinciding with the release 20 timeline of 3GPP. So this slide basically, the main takeaway is parallel paths happening, the ITU recommendations for 2030, and the 3GPP release 20 timeline, the study item descriptions, the work item descriptions, and that is work that is going to continue to evolve. And I think the key term or key takeaway is the evolution rather than a revolution here. So next steps, we talked about this workshop, the TSG-wide workshop that is planned for March. Multiple different, on the technology side, the study item descriptions are already happening. So this is work that's happening in different work groups and is targeted for September of this year. And I think, we understand and take the feedback quite seriously. And I think we can bring this back to the working group and think about how do we sort of compartmentalize the cost side versus the quote-unquote hype and the revenue side, and how do we sort of balance that in the advisements and recommendations we'll make. So with that, we'll switch to the IEEE side. Brian?
Okay, thank you. Yeah, I know we're running short on time, but I'll go through this fairly quickly. So we did have the benefit of bringing a subject matter expert from IEEE, and Dorothy Stanley from HPE gave us a good presentation and overview of some of the activities, both in the IEEE 802 as well as the Wi-Fi Alliance. And it was interesting to note, there's many working groups within IEEE developing new standards, and IEEE 802 is just one of those. There's a number of different standards in progress, which are listed at the bottom here. You'll see 802.11be through BP. Looking at things such as extremely high throughputs, wireless LAN sensing, randomization of the MAC addresses, as well as enhanced data privacy and ranging and ultra-high reliability and ambient power communication, all themes that we see in the 3GPP and the ITU as some of the themes that we're seeing for just general wireless evolution in general. Next slide, please. So Wi-Fi 6 and 6E, this does meet the MAC and physical layer requirements for 5G IMT 2020 indoor hotspot and dense urban test environments as defined by the ITUR. As I mentioned earlier, the ITU are the radio sector within ITU. They develop performance requirements for radio technologies, which get evaluated. And then the IEEE 802.11ax did meet the requirements for that IMT 2020, which in the 3GPP world we know as 5G. And again, I'm not going to go through each of the specific characteristics listed here, but those are defined and again met through the IEEE 802.11ax. Next slide. So 802.11be, there are features that are going to support both increased throughput and performance. This includes 320 megahertz bandwidth operations with 16 spatial streams and 4096 quadrature amplitude modulation schemes. They are looking at multi-band, multi-channel aggregation and operation, as well as multiple resource unit operation and MIMO protocol enhancements, all to get that increased throughput and performance. They are also looking at enhancements for lower latencies, as mentioned here, and again, in interest of time, I won't go through each of those, as well as 6 gigahertz support. Next slide, please. So one of the other areas they're looking at is wireless LAN sensing to detect features of an intended target in a given environment. And this includes things such as range, velocity, angular motion and presence or proximity, used to detect objects, people, animals, and enable touchless applications. It can be used in a room, in a house, in a car, in enterprise environments, across different environments. And the target frequency bands that they're looking at for wireless LAN sensing are both the 1 gigahertz and the 7.125 gigahertz, as well as above 45 gigahertz frequency bands. Next slide, please. They also were looking at ultra high reliability. There was a task group that was approved in September of last year. And this is looking at the reliability of wireless LAN connectivity in order to reduce latencies, increase manageability and throughput, as well as lower power consumption. The task group began work in November, and their specification framework document is under construction. Next slide, please. In the area of AI/ML, which again is an interest to the TAC, they do have a standing committee looking at wireless LAN support of artificial intelligence and machine learning, specifically looking at 802.11 applications. It's a very active area, looking at current research and emerging use cases. They've developed a report describing use cases for AI/ML applicability in 802.11, as well as investigating the feasibility of features to supporting AI and ML. Next slide, please. 802.11bd is the next generation of V2X use cases. And again, that's one of the ones we're going to be talking about momentarily as well, looking at the 3GPP aspects. They're looking primarily at the 5.9 gigahertz band and optionally 60 gigahertz. They did complete work in 2022 and was published in 2023. Again, there's a number of use cases shown here to support V2X. And won't go through these in detail. Some of the key additions are backward compatibility with 802.11p, as well as higher throughput, longer range, and support for positioning. Next slide, please. They're also looking at Wi-Fi connecting both vehicles and international infrastructure in space, which we thought was an interesting application for this. Again, they're looking at some of the plans for Artemis and Moon deployments. The first Wi-Fi in space network was installed in 2008, actually, with Wi-Fi 4. In May 2020, they also connected vehicles for the first time using the Japanese HTV-9 cargo transfer vehicle operated by the Japan Aerospace Exploration Agency. And, as mentioned here, it's hard to imagine that the space station without Wi-Fi, which the subsystem manager for the 802.11 wireless communication system on the International Space Station. Next slide, please. So there is also 802.11 working group standards development and Wi-Fi interoperability, Wi-Fi Alliance interoperability certification ecosystem that's been defined. The Wi-Fi Alliance has had a 25-year success story developing interoperability certification, market advocacy, and regulatory advocacy. And this is continuing, and will continue in the future as we progress the IEEE 802.11 series of standards. Next slide, please.
Okay, thanks, Brian. So that
Thanks.
was sort of, I think it was interesting to note there that the progression of what's happening in the 802 side is sort of mirroring what we just saw on the 3GPP side. So you're seeing intersection of SATCOM, AI, obviously in the context of unlicensed as well. So I think that whole hybridized architecture approach will be very, very important. And it's a very, it's very encouraging to see that the standards that are being developed somewhat have a little bit of twinning, even though, mission statements are a little bit different. So just wanted to dive in. Again, we have a very small sample size up until now, but hoping to bring more of this work in the following months. So we were able to dive down primarily into the automotive sector And we got a little bit of a kind of a primer on what the state of the art right now is with respect to 5G and the automotive sector. So obviously, this is work of deployment of 5G NR as it evolves towards satisfying a automotive vertical sector need. So V2X probably being the most notable example, and this is more kind of moving towards that extreme use case of your LLC beyond just EMBB. From that industry's perspective, the focus is on higher data rate, coverage extension, and lowering the latency, and also trying to address, and this was something around the device side I mentioned with Industry 4.0, is to address the quick refresh cycle associated with the chipsets that are going to be deployed in cars. The life cycle of a car is different than the life cycle of a handset, so that'll be very interesting to see how that sort of comes together. So when it comes towards evolution towards 6G, this was sort of the perspective presented on behalf of 5GAA, which is the industry body that's sort of participating in the standards work. And the evolution was to enable sort of new use cases and new services, which would allow you to address or demonstrate value in a more cost-effective manner, and leveraging what are the different components of the vehicle to deliver this services. So now you're looking at where should the antennas be placed, how do you sort of leverage the shape and the composition of the vehicle in terms of leveraging it for antenna technologies or for spectrum sensing as well. And how do you sort of provide these services in a more kind of the cost becoming another key thing. So this is the perspective coming from an industry side, and I think that was quite a keen observation that was shared with us. So what are the main requirements? Obviously, the headline, the bottom line up front is ubiquitous connectivity is the biggest factor that industry is looking at. They want secure, reliable, resilient, low latency, high mobility, an alphabet soup that's demonstrated. But I believe that's very, very important because there are issues around safety of life in an automotive sector, especially as you move towards self-driving or you move looking at vehicle-to-vehicle communication as well. And so that last bullet point around pedestrian protection, which is how do you provide location information? Can the vehicle leverage sensing technologies? Can you sort of pinpoint the location of a user equipment or a pedestrian less than a sub-meter? And what are sort of the technologies that will be looked at? And those are around resilient communication for automated driving services. So ubiquitous connectivity becomes very important. How do you sort of have service continuity? So how do you integrate terrestrial and non-terrestrial network architectures? And then sensing, whether it be inside the vehicle or using the vehicle as a sensor. And then the meta services piece as to how do you sort of do the placements on antenna of the antenna on the device. So these are all requirements that from that perspective are being brought into 3GPP. So that was just, a very, very kind of a very cursory look in how we want to explore that question that's been posed to us around multiple different verticals and how they're going to leverage 6G and what is their journey been on 5G so far. So we want to go down that path, but I think, we do take that feedback of the cost side and the availability side seriously. So these are sort of the speakers. Again, it's been a small sample size, but we really do appreciate their contributions. We have a bunch of speakers lined up for the following time. And sort of the way our modus operandi, similar to the other working groups, meeting every other week on Thursdays, 4 to 5 p.m. Eastern. And, we have additional sort of SME presentations. So if you are, we have new members that are being added, but if you are not there or if there was a charter item that you would like to contribute to, please reach out to myself or Brian. And then with that, I'll yield time back to you, Dean, and happy for questions. Brian, any last comments?
No, I think we covered it. Thank you.
Any other questions or comments? Great presentation, Manu and Brian. Thanks so much for everything that you guys are doing. And with that, thanks to everyone for a great meeting, and we will be in touch. Please continue all the great work that's being done in the working groups, and look forward to our next meeting, probably in the late August timeframe, to see the next level of output. Thanks, everyone.
There was a question online. There was a question online on the AIML group that you may have missed from Michelle.
Go ahead. What was your question?
Are there any questions online?
On the written, on the chat, yeah.
Oh, in the chat?
Can you read it out? Because I'm not online.
Okay, we'll deal, whoever it was can raise it in the working groups. Thanks, everyone.
Thanks, Dave.
Yeah, I
Take
bought
care.
it. I bought it.